Hello everyone, it's Benny, and I've got some good news, and I've got some bad news. So, I'm going to start with the good news. The good news is, as of this Friday, I am officially on winter break, which means I'm back. I can't promise I'll upload it on Friday. If I don't do it on Friday, it's probably going to be on Monday, but nonetheless, I am going to start uploading videos sometime at Friday or slightly after Friday. I think that's a fair statement. So, what I'm going to be doing at that point is I'm going to be working on the RPG series pretty much immediately. That's my first priority. I'm hoping to just do a simple cleanup video at first to ease back into the groove of working with this since you've been away from the code for 2 months. But after that, I'm going to sort of just work back into the mechanics and just keep going like we were before. So, that's the good news. And of course I will be working on the lightweight Java game library and OpenGL stuff, but that brings me to the bad news. So, believe it or not, I haven't just been sitting idle for the past 2 months and just not doing anything. That's, believe it or not what I've been doing at all. In fact, I've been doing lots and lots of research because, hey, even if I can't make videos, I can at least learn some new things that I can hopefully eventually teach you, right? Right. So that's sort of my logic there. And specifically, I've been learning lots and lots of modern OpenGL, like OpenGL 3.0 and up. And it's really interesting stuff. There's things like tessellation, there's lots of GLSL stuff. So if you're into GLSL, there's lots of that in modern OpenGL. There's really more things that I can talk about without going into a bunch of detail that would just bog down this video and get off topic. But the thing is, in modern OpenGL, a lot of the old ways, or in other words, the types of things I've shown in my lightweight Java game library / OpenGL videos, are deprecated. So things like GL Vertex and lights, I don't think I ever even got to lights, but GL lights, those aren't used anymore. GL transform is... It's not... I'll put say is not recommended, because I believe it's technically deprecated. I actually have not looked at that method specifically. But it's not the best way to do it anymore in modern OpenGL. So, there's a whole bunch of things like that. And that's sort of a problem, because it means a lot of the things that I've taught you so far really won't translate over. And my understanding of why they sort of changed everything is because in the old OpenGL, the old OpenGL uses something called a fixed function pipeline. It means essentially you have one function for everything you'd reasonably want to do. So for example, if you want to light, there's a GL light function. You want to move something around, GL translate. You want to make something bigger, GL scale. So yeah, things like that. You want a vertex, GL vertex. There's the big one. And the reason I say that's the big one is because the problem with the fixed function pipeline is, one, it's fixed function, meaning if you want to do something more specific, you are going to have trouble doing it. You have to build it out of all the existing methods, which can be done, but the issue with that is it requires a lot of method calls. And method calls aren't that expensive to do, but if you start calling, say, tens of thousands of them to start putting vertices and stuff, it gets kind of ridiculous, I'll put it that way. So that's my understanding of why they did it, and why they got sort of scrapped this fixed function pipeline and moved on to what they call the programmable pipeline. And that's where pretty much your only tools are a bunch of buffers. You have vertex buffers, you have frame buffers, and you have color buffers. So you just have this bunch of buffers that hold a bunch of data. And they'll be sent through your graphics card, and you'll be able to program what the graphics card does to it in each stage of the graphics pipeline. So for example, in the vertex processing part of it, you might say, okay, I want you to make all these vertices move up, or something, I don't know. And maybe in the shading part of the graphics card, you want to program it to make all the pixels blend between black and white. I don't know, I'm making this up, but yeah, that's essentially the idea of the programmable pipeline. You have all these buffers that hold all the data, and you just program yourself what it does in each stage of the pipeline. So you don't have methods like GL transform and GL light, which is one disadvantage because you can't just automatically do that. You have a method built in for you. But on the other hand, since you're getting to program everything in yourself, you're going to be able to do a lot more functions, and you'll only have the functions you need, and you'll be able to make really efficient functions because you don't have to rely on all these sort of underlying functions. You'll have direct control of the data. And that's sort of the advantage. You don't have to make 10,000 method calls to draw an object. You can just put them all into the buffer and just say, okay, draw the buffer. One method, one function, done. And that's sort of the big thing here. And I know I didn't have to explain that all. It's probably a little bit off topic, but I wanted to at least give you sort of the idea of how this works. And you might think, okay, well, we'll just start over with the new thing. And that's one of the issues, yes. But unfortunately, I've come across yet another issue which deals with this modern OpenGL stuff. So, yeah. And here's sort of the problem. OpenGL isn't written in Java. In fact, there's no Java code anywhere which explicitly implements any OpenGL function. In fact, OpenGL itself is written in another programming language called C. So when you're using OpenGL functions in Java, they aren't actually doing any real functionality in terms of graphics, because that code doesn't exist in Java. So what libraries like Lightweight Java Game Library and Joggle and pretty much any Java library does is they'll have these things called natives, and what the natives will do is they'll just have all the C code, well, the compiled C code for all of the OpenGL functions, and when you call the OpenGL method in Java, the library will take that method, it'll take whatever you execute, it'll take all the parameters, and it'll just pass it through to the C implementation of the OpenGL method. And that's sort of... it is sort of a hack, but it's what lets you use OpenGL in Java. So that's sort of... well, that itself isn't the issue, but just in case you wanted to know, hey, that's how Lightweight Java Game Library works. That's all it does, pretty much. So, but the reason that causes a problem is actually because of the way the language C and Java differ. And it's not so much a problem in the fixed function pipeline, but in the programmable pipeline, it causes a really significant issue. In C, you have this type of data called a pointer. And a lot of people try to make pointers out to be something really complicated, and a lot of people really try to overthink it, but pointers are actually really simple. All a pointer is it's a type of data, just like an integer, just like double, just like float, just like character, just like anything. And what a pointer stores is a location in your computer's memory. That's pretty much all a pointer is. That's all there is to it. It's not big fancy, that's all it is. And both Java and C have pointers in them. The difference is, in C, it lets you explicitly control pointers. So you can explicitly say, okay, I'm going to store this memory location, and now I want you to write a bunch of data at this memory location, for example. And in Java, it still does that when it needs to, but it completely masks it. So you can't explicitly create a pointer in Java because all the pointer stuff that's done is hidden from you. And that in and of itself isn't a problem, because as you see, Java works absolutely fine without you having to explicitly use pointers. The real issue comes in graphics programming. And I think the best way of thinking about the issue is like this. If I want to store some data in the computer, there's two ways to do it. Either for every piece of data, so let's say my piece of data is a vertex, for every piece of data, I can save and keep track of each one individually. That's one way of doing it, and that's a perfectly fine way of doing it. Alternatively, what I can do is I can just save all that data in one big block of memory, and I can just use a pointer to tell me where that block of memory is, so that I don't have to keep track of every piece of information individually. And that's sort of where the issue and the big problem in implementation comes in. In the fixed function pipeline, they seem to tend a little bit more towards doing things with the first way of doing it, where you just keep track of everything individually. If you want to draw something to the screen, you just send in each vertex individually, and then it'll process it. And yeah. Except, of course, that's slow, because you have to send everything individually, and that causes a whole bunch of the issues that I talked about earlier, which I'm not going to go over again. And that the modern OpenGL implementation, it'll take the more block approach to saving it. You'll have this huge piece of data for all your vertices, this huge block of data, and it'll just say, okay, send this block of data over to the graphics card, and the graphics card will do whatever it needs to with it. For example, drawing it to the screen, or maybe it'll be doing some interesting graphical manipulations with it. I don't know. So, yeah. And the problem that sort of arises from this is, in order to keep track of your block of data, it's pretty much unavoidable. You need a pointer of some form or another. You need to know where that data is to interact with it, unless you fundamentally change the way modern OpenGL works. And libraries like Lightweight Java Game Library, they make some really interesting maneuvers to get around all that. And really, Java itself does a lot of interesting maneuvers to get around issues like that that crop up in graphics. The problem with doing things like this, though, is the solutions aren't particularly pretty. For example, the Coding Universe, who also does tutorials on Lightweight Java Game Library, he once did a tutorial on how to set up VBOs using Lightweight Java Game Library. Again, those are the sort of modern OpenGL way of handling vertices and stuff. When he did his tutorial, he did a 26-minute long tutorial on it, and he did, I believe, it was a ridiculous amount of code to get it all working. And you had to store stuff in float buffers, you had to flip the buffers, you had to do interesting... you have to do some really interesting things. I'll let you watch the video and find out for yourself if you're interested. I mean, it's a good video. It does a very good job of describing how to do VBOs in Lightweight Java Game Library. And if you're not subscribed to him, if you don't watch his videos, I strongly recommend them if you're interested in Lightweight Java Game Library, because I believe he does the best out there right now. So, yeah. But, back to the point, he did an absolute ridiculous amount of code to do VBOs. If you want to do that in C, where OpenGL is a native and you have pointers and stuff, you can create a VBO in 3 lines of code, and you can draw a VBO in another 3 lines of code. Sometimes even 2, depending on how you do it. And his implementation, he took 10 lines of code to draw it, and he took about 10 lines of code to set it up. So, that's going to become a huge pain to do that for every single one. Just look at the coding differences. I know that 7 lines of code doesn't seem like that much more, but when you're doing this for a lot of things, it becomes a bit of a pain, especially when you consider that this is sort of how it works for almost every modern OpenGL thing in Lightweight Java Game Library. And that's really the big issue overall here. Lightweight Java Game Library, and really Java libraries in general, don't have a particularly good way of getting around the issue of pointers. They have very, I guess you could say, unpleasant ways of handling it. They work, and they work efficiently, but they're not how you want to handle them. So here's sort of the impasse we're at. And at this point, we have a few options for getting around it. So, option number 1. We can just completely ignore doing modern OpenGL, because it isn't required, it's just more efficient, and that's the way things will be done from this point on. So we can continue the series as it is right now, learning old, deprecated OpenGL code, and then we can just continue like that. It won't be as efficient, it won't be up to date, but hey, it works. So, that's one option. Now, option 2. We can pretty much start that series over. We can pretty much just restart using the new programmable pipeline, which will be up to date. It'll be more efficient, but then you will have to pretty much relearn a whole bunch of different things using this new programmable pipeline. So, there's that. And in this option, we'll be doing it still in Java, still with Lightweight Java Game Library, still with everything. So, there's that. And that means, of course, that all the modern OpenGL implementations will be very hackish. The OpenGL methods will be sort of distorted from their actual C implementations, their actual C counterparts. And you have to do a lot of workarounds to get things to work. This way of doing things will inevitably be very buggy, but it'll work, it'll still be in Java, and you'll learn modern OpenGL. So, then there's option number 3. Option number 3, we can get the obstacle of Java out of the way. We don't have to handle any of the weird hackish stuff, we just work directly with the C implementation. Now, that being said, I will not, if you choose this option, I will not be doing the tutorial in C, because C is, for the most part, the way it's done is outdated. Most people, given the choice, probably don't want to work with C anymore. So, unless you can give me a really good reason to do it in C, I'm not going to do it in C. I will be willing to do it in C++, though, which is like C, but better. It has everything C has, and then some. And this is fairly close to the way Java works. You have classes, you have objects, you have methods, and even the syntax is pretty similar. Java's syntax, in case you didn't know, is actually based off of C++. So that's option number 3. Option number 3, we restart, so we're going to have to relearn everything. That's the big con. Was one of the big cons there. But that'll all be up to date. And in option number 3, we'll do it in C++. So, on top of having to relearn everything, if you don't know C++, you'll also have to know C++. Now again, it's pretty similar to Java, so you probably know more about C++ than you realize, even if you don't think you know it. But, that being said, you'll be able to do it like that. So, yeah. And just saying, if you do pick option number 3, if that does end up being the consensus, if there are enough people who don't know C++, if that is the consensus, that we just start this new series in C++, and again, the advantage to that is you don't have to handle any of the weird hackish stuff. You get to learn the direct C implementation of OpenGL, how methods were intended to be used, which might be another advantage to doing an actual implementation rather than the wrapper and the workarounds. If you choose to do it like that, 1, I will make sure to make the code as cross-platform as I possibly can. I'm pretty sure, in fact, I know it's possible to make it completely cross-platform, but I'm only using Windows, so I'll do what I can to make everything cross-platform. Which pretty much means it will be cross-platform, so you won't have to worry about platform issues. So that's just one concern there. And if enough people say that they want that option, and enough people don't know C++, I'll be willing to do a tutorial series on how C++ works, so you can learn if you don't know it. And again, it's really not that much different from Java. If you know Java, you know more about C++ than you realize. But if people really want it, I will do a basic tutorial on C++ so people can get up to speed on how that language works. So those are really the 3 options. And, well, I suppose there's also secret option number 4, which is, Benny, you're an nincompoop. We don't want your OpenGL tutorials, so you should just go home. So I suppose that's an option too, if you really want it. So, but yeah. So there's also 4 options then. And if you want any of these options, I'd really like to hear about it. Which option you want, and most importantly, why. If you just say, hey, I pick option 4, that doesn't tell me anything other than, well, you think I'm a nincompoop, and that doesn't help me produce the tutorials. If you want an option, I really want to know why more than anything else. Because I want to do these tutorials in the way you, the viewers, the people who are actually going to be watching them, want to learn them. So, it's your choice. I really would love to hear about this, because this is a big issue, in my humble opinion. So yeah, hope you enjoyed, hope you learned. Well, I suppose you did learn, since I did talk about a fair number of OpenGL topics, considering it's an update video. But, yeah. So, In summary, I'm back. We have the OpenGL problem of how do we handle it, and those are the three options, and there's sort of the rundown of what the issue is and why. And yeah, so thank you. Hope you enjoyed, and see you. Actually, wait a second. I just want to say that for the OpenGL issue, that will be sort of in the future. I'm not going to be restarting it immediately. My primary goal at this point is to finish the RPG series. So, I'll still be doing... I might still be doing... I'm not going to say I will be doing, but I might still do a few OpenGL tutorials in my other series, just if people want them. That's a might, since I'm planning on scrapping everything, possibly. I'm not saying I will, because, again, it's up to you, but it's an option. It might happen. So I'm sort of discouraged from working on that right now. But, yeah. So, all of this new series, if it happens, all that will be in the future. So, yeah. Now, thank you. Hope you enjoyed, hope you learned, and I will see you next time.